Hi everyone. Let's talk about inequalities. We have done equations, and just like inequalities, we are going to use algebraic thinking and properties of equality to solve them. But of course, they have some minor differences between inequalities and equations, not the least of which is the definition, right? An inequality, for instance, is a statement that two quantities are not equal. An equation says they are, an inequality says they are not. And you've used inequalities before, right? We've said things like 5 is less than 7, or 10 is less than 25, or 25 is greater than 10, right? We can do these things. You can do these things with variables too in algebra. Like we could say r is less than 7. We can say n is less than 25. We can say m is greater than 10. Those things work. If it turns out when we solve our inequalities, we have a bunch of numbers that are in fact less than 7 in this case, or a bunch of numbers when we solve this inequality that are less than 25. Now, one thing that's different with inequalities is we can also say less than or equal to. R could also be equal to 7, which means 7 might be in the solution set. N could be less than or equal to 25 if 25 is included in the solution set. M is greater than or equal to 10 if 10 is a solution in that equation. Let's talk about how we graph these things. And then we're going to talk a little bit about how to write some. So let's say we have r is less than 7. Let's graph that. Here's 0. Let's say 1, 2, 3, 4, 5, 6, 7. It's not going to be even. R is less than 7. Here's 7. Well, 7 is not included in the solution set. It's just less than. All numbers less than 7 are a solution to this particular inequality, which means we would graph it with an open circle on 7 and an arrow pointing in the less than direction, which means all of the numbers less than 7 are a solution. In this case, if we said r is less than or equal to 7, get our little number line here again, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I like symmetry, that's why I do that. In this case, we have a closed dot because it includes 7. It doesn't include anything to the right of 7, but it includes anything to the left of 7, anything that is less than. And we indicate the arrow with the arrow that this is infinite, goes on toward negative infinity. Same with r less than 7. Okay? Let's graph this guy. If we were to graph, say b is less than negative 1.5, notice it's just less than, not less than or equal to, right? It's just less than. So it's not going to include the number negative 1.5. There's 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So negative 1.5, we're going to go to the left. 1, there's 2, so we're going to be between 1 and 2. So here's 1.5, right? Only, we're not going to include that point. I'm going to say open circle and everything less than that. How about this one? Let's do one more, but I have to erase these little dots because they're bugging me. Okay, how about let's say r is greater than or equal to 2? Well, because we have this little equal sign there, we know that 2 is included in the solution set. So we're going to graph 2 with a solid dot. Here's 1, 2, negative 1, 2. Here's and we graph by including the point on 2. And in this case, we're going to go in the positive direction because our solution set is everything greater than 2 or equal to 2. So it's 2 and everything bigger than 2. Okay, so that's how we graph them. How do we write an inequality from a graph? Let's practice that, shall we? Let's do. I knew I had another one on there. Okay, so let's say we have and let's graph it in the positive direction. So the open circle on 4 says that 4 is not part of the solution. It's not a solution. It's not in the set of solutions for this particular inequality. What are the points that are in the solution set for this particular inequality? Well, we're graphing in the positive direction, right? We're graphing to the right. So it's going to be all things greater than something, right? Let's say all points x greater than, well, what is our circle on? It's on 4, right? Which means all the points greater than 4, if we substituted them in for x, would make this a true statement. And we can check that, right? We can pick, like, say, a point right here. We'll call it 4.5, and substitute that for x. Is 4.5 greater than 4? Well, yes, it is. How about 5? 5 is greater than 4. All of these points are going to make this statement true. All of these points are going to make this statement true. And that's what we're looking for. Just like with equations. Okay, one more. No, and then we'll practice writing from words, right? Practice writing an inequality algebraically from words. Okay. Let's say what would you say the inequality is for this guy? Well, we see that negative 3 is included, right? So we know we're going to have an equals with our inequality. But is my x less than negative 3 or greater than negative 3? Which direction am I pointing? Pointing in the negative direction, right? So I'm going to have all points, and let's call them s instead of x. All points s, all right, let's not use that. There we go. All points s less than or equal to, right, because we have a solid dot, negative 3. And if we take some test points from this graph and plug them into, for s, into this inequality, they should work, right? So let's find out. Let's take negative 32. Is that less than or equal to negative 3? It is. I mean, it's not equal to negative 3, but it's certainly less than negative 3, right? Because the larger negative number is, in fact, a smaller number. Okay, so let's practice writing, or let's at least look at how we would write an inequality from words. If I were to say to you that we need, let's say, some number less than or equal to 5, we would say what? Some number less than or equal to 5. What would we be even talking about? Let's say t less than or equal to 5. What about if I told you only children under the age of 12 are allowed in some place? How would you write that? Only children under the age of 12 are allowed. I'm going to let you guys work that out on your own in your notes, and we'll talk